Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to solve another problem. So let me give you the problem first. The problem goes like this. In an ionized helium atom, that is a helium atom in which one of the two electrons has been removed. The electron and the nucleus are separated by a distance of 26.5 picometer. What is the electric field due to the nucleus at the location of the electron? So this is our today's problem. Let me check it. In an ionized helium atom, a helium atom in which one of the two electrons has been removed, the electron and the nucleus are separated by a distance of 26.5 picometer. What is the electric field due to the nucleus at the location of the electron? So we have helium atom which is ionized. You know the atomic number of helium is 2. That means in this its nucleus there are 2 protons, and in extranuclear part there are 2 electrons, but it has been ionized. Its 1 electron has been detached. So it has only now 1 electron in the extranuclear part. The question says now this electron and the nucleus are separated by this much distance. And you know 1 picometer means 10 raised power minus 12 meter. So what we are asked to solve for is the electric field due to nucleus at the location of the electron, right? So you know the expression for the electric field. So let us move to the solution. Expression for the electric field due to a point charge is, expression is E is 1 over 4 pi epsilon q by r square. That means if I have a charge q and I select the point P, r distance from this charge, then at point P, this much electric field exists, right? So this Q we sometimes call source charge. You can see the electric field at point P is proportional to the magnitude of the charge and inversely proportional to square of the distance. And you know electric field is a vector. If this source charge is positive, then this field at point P will be radially outward. If source charge Q is negative, then the field at point P will be radially inward. Now we are asked to find the magnitude of the electric field. So the problem is we have this nucleus of ionized helium atom, ionized helium atom, and we have an electron in it. Distance r is given. Distance of separation of the electron and the nucleus, 26.5 picometer, right? Now we have to find the electric field due to the nucleus at the location of the electron. That means this point is our point P, this point P, and this nucleus is our source charge. So it is simple. It's our source charge, right? So let us solve. So we take this nucleus as a point charge and use this expression. So electric field is 1 by 4 pi epsilon naught q by r square, and you know we are assuming this expression that our charge is placed in vacuum. Let us put the numbers. Value of this constant is 8.99 into 10 raised power 9 Newton meter square per coulomb square. Then what is Q? Our Q is plus 2e. Why so? As I said, the nucleus of helium contains 2 protons. One proton has charge of plus e. So the source charge becomes plus 2. Let us put the values, and you know the value of E is 1.60 into 10 raised power minus 19 coulomb. So our Q is now 2E. That means 2 multiplied by the value of E, which is 1.60 into 10 raised power minus 19 coulomb. Then we have R square, where R is 26.5 picometer. Now we convert it into meter, so I write 10 raised power minus 12 meter whole square, right? 1 by 4 pi epsilon naught q by r square. Let me check it. Value of constant 1 by 4 pi epsilon naught is 8.99 into 10 raised power 9 Newton meter square per coulomb square. Then we have Q 2E. 2 times E is 1.60 into 10 raised power minus 19 coulomb. Then in the denominator we have R square, which is 26.5 picometer. So we convert it into meter. We write it 26.5 into 10 raised power minus 12 meter, and there is square. When we make the calculation, it turns out to be equal to 4.13 into 10 raised power 12 Newton per coulomb. Let me encircle it. So this is the answer. But as always, when you check it, at home. You have to simply make the calculation and check this value. So the magnitude of the electric field due to the nucleus of ionized helium atom at the location of the electron, which is 26.5 picometer away, is 4.13 into 10 raised power 12 Newton per Coulomb. And it is a magnitude, and the direction will be radiating outward because the nucleus is positively charged. So this is all for today. Go through all the problems. Don't waste your time. It is interesting to solve or discuss a problem. And don't forget to like, subscribe, and share my channel. You can comment in the comment box as well. Thank you. God bless you. Assalamu alaikum.